All right, guys. Today we're going to be looking at regression analysis, and it's really pretty straightforward. And what is a regression analysis? It is the process of finding the equation, the model that fits the data points. Scatter diagrams, basically these are scatter diagrams, and they are the XY pairs being plotted on the graph. So it's pretty straightforward. So what you want to picture here, though, is the following. You see that through these data points, you can visualize that there's got to be a line that fits through them. You can see the trend is taking place, getting y increases as x increases. So relating that back to our r value, we should expect the r value to be positive in this case. And because you can see the trend is pretty straight, it shows it's fairly straight. You can see the correlation should be fairly strong. Likewise, over here, we have an R value that should be negative, right? Because it's going down as X increases, Y decreases. And, relative to this value, we'd say that this is even stronger, right? Because you can see the points line up. Now, the question is, how are the points, how is this line actually figured out? And we're going to keep it really simple. Your calculator actually takes care of all the math for you. But basically what you have to visualize is the following. So here's the definitions. Regression line, the line that best fits the data. The regression equation is the equation that fits the data, the actual equation. And we are going to model this since it's a straight line. You remember mx plus b? Well, in this case, we're going to be using this, right? But your calculator actually has two built-in values, and it's going to look like this. Now your calculator, when it displays the values, you'll see that when we go into to our stat function, it will give you b and a. So it's kind of backwards. We know that you've probably memorized to death over the years that y is equal to mx plus b, b being the y-intercept, right? In this case, when the calculator gives you the values, b in this case is actually going to be the slope, all right? And the a value that's given you is the y-intercept, all right? So just keep that in mind. Okay, now, so if there seems to be a relationship between the two variables, then a linear equation can be determined. Now, this could also be extended to values that are logarithmic, exponential, quadratic. So we're just dealing strictly with one straight line, okay? But there could be more complicated models. This being the COVID period because of the pandemic. If we were to plot the points, you would see that actually in that case we would get sort of like a logarithmic, exponential set of points. They would go something like this, where it's increasing rapidly. All right, so that's an aside. We're just going to be keeping it really simple. We're after a line that best fits through the data. So we would first put the data in. We'd say, is there a strong relationship? Is R very strong? And if so, then we can progress and say, well, based on our data, we should be able to come up with a model that best fits the data points. Now, how does that actually work out? Well, it's worked out based on the least square criteria. Okay, and this is what takes place here. So we look at the line that best fits through data with the smallest possible sum of errors squared. All right, sounds complicated, but let's just picture this for a second. Here's our set of data points, right? And here's our line. So here's the model, and here's the error from each data point. All right, so we would expect error here, here, and so on and so forth. So you can see that if we were to shift this line, suppose we shifted it upward, this error gets smaller. Same with this. This, depending on where it pivots, can also be brought down. So this error increases. At the same time, this error would increase and this would increase. But if you picture them as squares, right? Each one of these is squares. Then we're moving it in such a way that when we pivot this line either up, down, and depending on how it pivots, the area of the squares is such that it's the smallest possible area, and then that means that that's the line that best fits through all the data. So that's what's going on mathematically behind the scenes. We don't have to worry about that. Like I said, inside the calculator, all that's taken care of. We're just interested in saying, okay, what is the model that best fits through the data? Let's take a look at our first example. And here we go. It says we have sales and ads per week. Okay, so which is the dependent independent variable? Well, you could picture that sales should go up depending on how much advertising. So in this case, this is your independent variable, and that's your dependent variable. It's asking determine the linear regression equation, and then we're going to say, well, based on our model, what should we expect if we had put 4 ads in per week? So first thing we want to do is actually put the data points in. So let's make that happen. So in case you missed the last lesson, we would go through and first of all make sure you're in the proper stat. So second stat, make sure you're in linear mode. If you're not, suppose you are in a different mode. This is what I expect you to be in because you would have just finished the assignment. One variable. So if you're in one variable, just keep hitting second enter until you get to linear. And once that's in there, we're going to go to our data, second data, and we want to clear, second clear, so that there's nothing in there, and we're going to put in the values, right? So 2 for our X value, and it has, so 2 ads corresponds with sales of 3,500 for that week, or month, or whatever the time period was. It's per week. 3 ads, we should expect sales to be 5,500, and so on and so forth. So I'll let you finish up entering the data. So after I entered my data, I double checked to make sure everything's in correct. And what we're going to do is go to second stat, and we'll scroll down. So we have 7 data points. We have 7 points here. 1, 2, 3, 4, 5, 6, 7. Okay, and the mean of the x's, if we take the average of the x's, it's 5 average on average 5. Standard deviation for your number of ads per week is 2.3 and change. If this was a population, 2.1, and then you'll see that you get the same values for the y. With that said, keep scrolling, and here's the value that I want you to pay attention to. There's your A and there's your B. So let's write those down, and then we'll put them into the equation form. So we should get the following. And we have our model here, right? And like I said, from the calculator, your A is your y-intercept, and your B is your slope, okay? So we have the following. Now, the second thing we want to do is predict when we had, I believe it was 4 ads per week, what should we expect the amount of sales to be? So basically, we're just going to put in a value in for X, and we'll be able to calculate that. So let's do that. So when we did this, and we plugged in 4 ads in for X, I got the following mathematics, and I got this. So we should expect our sales to be $7,642 and change. Notice once again, I didn't round. If I ask just for this, then I might suggest rounding to 3 decimal places, but I always want you to show me the unrounded value. In this case, it's not always going to be perfect. The B value can be a decimal value as well, but show me the unrounded values first. Now this calculator actually allows us to do this calculation very easily. If you scroll down again, you'll see then, well, here's the R value, right? And you can see very strong positive relationship. The more ads you put out, the higher the sales is what this is really telling us. And if we go to X prime and we put in 4 enter, right? And we scroll down and then you hit compute, well, there is your answer right there. So it's the same thing, right? Exact same thing. We get that. Okay, so that's the shortcut. Okay, so but I do want you to express the equation, and if I ask you to estimate at a certain given value for X, then you just plug it in and either do it mathematically or use the built-in function. With that said, let's take a look at the second example, and then what I'll do is I'll come back and actually, you know what? Let me put together a scatter plot for this data. So in Excel, I plotted this, and so it's ads versus sales, ads per week, and sales in dollars. And if you actually go and you right click, you should be able to add the trend line. Okay, and it's linear. All right, and there we go. And as well, you can actually display the equation on the chart and the r squared value as well. And actually, let's put the intercept in here. Okay, and we should expect, there we go, intercept. Okay, actually, disregard that, not important. But the intercept is basically if this line extends beyond. The thing is that anything beyond these points, we don't have data. So we can only speculate that between 2 and 8, we would never expect anything to go beyond our given data. Okay, so there's limitations. We don't know what happens here, and we don't know what happens here. Anyways, it's pretty straightforward, right? Adding the trend line. And so here's our model, right? And the question was, if we had 4 ads, what would we expect in terms of sales? We go across, and that's where that number is, that's 7,600 and change. Let's look at the second example, and I keep it really straightforward, really quick, okay? So in this case, we're looking at sick days and age, and which is the dependent and independent variable? Well, you can see that sick days should depend on age, right? So this is going to be your independent variable, and that's your dependent variable. Okay, so number of sick days depends on age. Putting this data in, what did you get for an equation? I got the following. Take a second to do it, and then so you can pause, and then we'll check. And when I put my data in, this is what I got. So, oh, I've got my x prime here. So let me put the x prime. Okay, so we got this and this. So once again, this is your slope, right? And this is your y-intercept. This would be your b on your calculator and your a. Now, the question was asking how many sick days, predict the sick days when a person's 30 years old. So we would put in 30 in for here, and we would get the following. And then the final answer is as follows. So when I plugged in 30 into here, mathematically, if you do this by hand, make sure that it's times the negative value and then add 20. In the end, I got 10.9. But once again, if we scroll down here, I'm going to put in 30 for x and then compute, and that's where I got that number from, right? So get the same number, whether you do it mathematically or use the built-in function. Once again, what does a scatter plot look like? Well, you see that the slope here is negative, right? The slope here is negative, and as well, if you take a look back at your r value, it's negative as well, and it looks like there's a high correlation. So as a person increases in age, the number of sick days they take actually goes down. Once again, the scatter plot looks like this. So in Excel, I've got this, and once again, if I click on or right-click on the point, or click on the point and then right-click on it, we'll add the trend line. Okay. Once again, select linear, and then we can add the equation as well as the r squared value. And there we go. Once again, we can't predict anything less than an age of 20 because we don't have the information, or anything beyond 60. All we can speculate are between the values that we have collected the information from. With that said, I think this should be fairly straightforward, and I don't expect any difficulties. What we're going to do next, though, is we will be taking this this graph, and we're going to be predicting a confidence interval. So, a person's 30 years old. We know that based on our model, it's basically here. But in reality, there's going to be a bit of error. So we're going to come up with a range of values that we should expect with maybe 99% confidence that that would be the total number of sick days or what have you. So that's our next mission. With that said, you should be able to handle the homework very easily. Take care, guys, and see you next time.